Good morning and good afternoon, everyone. Welcome to today's webinar on powering progress, innovations in charging solutions for off-highway mobile machinery. This webinar will last approximately 30 minutes, followed by a 10 to 15-minute live Q&A session at the end. And this webinar is hosted by Zappi Group's Charging Solutions. If you are not familiar with us, Zappi Group offers a range of charging solutions from 350 watts to 36 kilowatts under the Zvan and Delta Q Technologies brands. Both Zvan and Delta Q are leaders in charging technology for industrial, commercial, and recreational vehicles and are based in Italy and Canada, respectively. My name is Akanksha, and I am the Content Marketing Manager here at Delta Q Technologies and today's webinar moderator. Our speaker for today's webinar is Rod Darrett. Rod is our Global Director of Business Development for the Charging Solutions business at Zappi Group. He has been with the company for over 6 years and has over 23 years of experience in new product development and lifecycle management. He carries with him a deep technical understanding of design and development in the electrical field. Before I pass it off to Rod to begin the webinar, I'd like to explain how you can submit questions on the Zoom platform. First, you would have to click the Q&A button on the toolbar as shown in this image. A text box will pop up where you can type your questions. You will be able to submit your questions anonymously by clicking the Send Anonymously button if you choose to. Please feel free to submit the questions throughout the webinar. We will address them during the live Q&A session at the end. Now I'd like to pass it off to Rod to start the webinar.
Thank you, Akanksha, and welcome everyone to this session. I'm looking forward to walking through this journey with you. As you could see from the agenda topics, I want to start off with the electrification journey because it's very important to understand that, especially when it deals with off-highway mobile machinery. I'll walk through some of the innovations with charging solutions, charging technology, and how it's relevant in the off-highway space, show some case studies, get into the depth of the Zappi Group and system integration, because I know that system integration at this point, during the transition and development phases for off-highway mobile machinery is a sticking point. And then we will finish off with understanding a little bit more about the offerings from the Zappi Group Charging Solutions, and then we'll go to live Q&A. So as Akanksha said, feel free to ensure that your questions are being asked by clicking on the Q&A box below on your screen, and I will try and answer your questions as best as possible. So let us begin. Oh, apologies. So we start off with EV adoption. So as you see on the screen, the 3 different market verticals have different levels of adoption. There's a multitude of reasons, but primarily it's related to greenhouse gas emissions, right? Material handling has been at the forefront of electrification for years, if not decades, because of the usage of their products indoors, right? So if they're operating their vehicles, they need to be able to do it in a way where there's no emissions being exuded, especially for the indoor applications. So they have a level of development and maturity with electrification. A lot of those lessons learned actually paved the way into the automotive space. You're starting to see it now. Automotive e-mobility, as the slide says, it's pretty much the largest contributor to greenhouse emissions. So there's a lot of regulations dependent on which region of the world you're located. but a lot of regulations pushing OEMs and the market to move to less greenhouse emissions vehicles due to the impact on the actual climate itself, right? So you're seeing automotive vehicles, automotive EVs in the marketplace right now, and it's going through certain iterations itself. Off-highway vehicle transition to EV is just at its infancy. There are some examples of adoption of off-highway vehicles, but it's really just begun. It's nowhere at the levels of the industrial side as well as automotive. But one thing's clear: a lot of lessons learned from each of the developments within the respective markets have been taken into consideration when looking to transition vehicles in the respective markets. When you look at adoption, it really goes in phases, and this is a trend that we've been seeing and monitoring. It goes in phases because of the current technologies that are out there with respect to the output power needed for these vehicles. The reason why you see on the left photo is because vehicles under 30 horsepower, or traditionally are under 25 horsepower, could operate in the range of low voltage DC. And when I refer to low voltage DC, I'm referring to anything under 120 volts DC. And that's related to a lot of safety precaution and regulation when it comes to touch safe electricity. You're starting to see the migration of off-highway vehicles that have higher power needs with the adoption of higher voltage, higher power drivetrains that have culminated through some lessons learned and developments on the automotive side. So on the automotive side, they're strictly high voltage, either 400 volt DC or 800 volt DC, within that range, so give or take some margin. But a lot of the higher power have moved to higher voltage because of efficiency gains that they would have with the higher voltages. And then the commercial sector, right? So there's rules, regulations, and a lot of push within the marketplace to electrify or to lower carbon emissions of these vehicles. And the biggest driver to lowering that is electrification. So when you think about the actual development of an electric vehicle, you really have to look at it in different generations, right? So when you first start the electrification process of a mobile vehicle that has not been electrified in the past, you're really trying to get to the level of performance at or above the incumbent solution, which is typically an internal combustion engine-based drivetrain, right? So you want to get to that level, if not better, so that the feasibility of replacing or transitioning away from that combustion engine is there, right? Is present. With that said, you take a lot of OEMs or original equipment manufacturers take standardized off-the-shelf product, whether it's something that was developed for their market or for parallel segments. They devise a system-based solution that in market is at or above the current technology. The only issue with that is it usually comes at a higher cost point. And you're seeing this in the automotive space with higher cost EVs trying to penetrate the market, but incentives are needed from the government, or if you want to purchase that vehicle, it's actually at 1.5 to 2 times the cost of the traditional vehicle. Now you've proven out the technology is good enough. what are advancements and iterations that could be done. So one of that is to start integrating solutions and systems together, subsystems together, so that number one, it actually reduces the cost of the bill of material or components, right? Number two, it reduces the time to revenue because development is now done in subsystems instead of through all discrete components. And then number three, it basically reduces the risk of any issues happening during development because now more of the onus is being pushed down the supply chain to the actual suppliers integrating these solutions instead of the application developer having to do the system integration itself, right? So there's more and more push to integrated solutions in the generation 1.5 that enhances the performance, but also reduces the cost. You get into the second generation, and then you have fully integrated subsystems, right? So now the application OEM is concentrated more and focused more on differentiating the application within their respective market or application vertical, right, from their competitors in their landscape, instead of having to really focus on system integration. There's minor system integration because you have to take the subsystems and integrate them together, but most of the development has already been done from either the component suppliers, third-party system integrators, or some other form or fashion outside of that realm. So that saves time, that saves reliability, that saves in cost, and that also saves and that also enhances performance because now you're relatively integrating solutions that have been enhanced for that respective function. So that's the electrification journey. Now, when you start talking about chargers and power electronics and the like, it really follows that same evolution and that same train of thought, right? So you go to proving out the application in the respective market. In this case, the off-highway mobile machinery. They take products that are already out there in the market, because if you think about off-highway mobile machinery, there may be a large addressable market, but for the specific vehicle itself, the actual scale of that market is not that large. So taking whatever's out there and leveraging it from other markets would be their best first pass to integrate those solutions and prove out the solution and its capabilities to either be as good or better than the current solutions with internal combustion engines in the marketplace, right? As you start refining that, making progress in terms of performance enhancements that go above and beyond what the current internal combustion engine could provide, right? So more connectivity, more digitalization with the vehicle, more remote monitoring, having the ability to understand and have the vehicle connected with the Internet of Things. You start fine-tuning the substructures of your development. And as you see in numbers 2 and 3, we start integrating certain power electronic components into the onboard charger. The reason why the onboard charger is usually the hub is because that component is connected to the battery, right? And the battery is one of the largest costed bill of material components that power the drivetrain, the motor, and what propels the traction and movement of the vehicle. So the charger is the one that makes the most sense to be the hub. And there's functions like the DC to DC converter, EVCC, or connection to EVSE, which I'll talk about later later in the slides. Having a converter to load solution that you're seeing in some of the automotive vehicles right now, but are really relevant when it comes to off-highway vehicles. And then number 4, the fully integrated solution. So this is where you basically wrap all of those functions and just put it in one box. Now, I might add that this is a future solution. There are some options out there, but they're very scarce. This is where the industry is going to with respect to the off-highway mobile machinery space when we speak about power electronics. So that's with onboard charger, AC export power. So that's the vehicle to load type scenario, DC to DC converter, maybe a power distribution unit, the EVCC, so the interface between the vehicle itself to EV charging stations and the like. And there's more functions that could be added in the future. But what I'm trying to highlight here is the integrated solution. So charger integration with system level components is really what is in line for innovation that we see in terms of trends. When you start talking about this, though, you also have to understand the levels of flexibility versus cost effectiveness, right? So it might sound like the all-in-one solution would be the best end-all be-all component to fit your needs future forward, but you also have to remember the flexibility to make any changes or to modify changes or capabilities on that is less and less prevalent, right? So just take an example of an 11 kilowatt onboard charger, and you have a 3 kilowatt DC to DC converter on board. Say your application needs a higher DC to DC power load, right? Or has a higher DC to DC power load, and you need to have maybe 5 kilowatts, right? It's harder to actually modify that piece of hardware because it's a one-stop shop type solution, rather than if you had discrete components, you basically could just add on another DC to DC converter or add on a bigger DC to DC converter and whatnot. So when you're looking at all these challenges in front of you and you're trying to do component selection, just know that albeit cost effectiveness might be better because you're saving on the cable interconnects, or you're saving on the cost of the enclosures of all these different components because they're now under one housing, right? You also have to know the flexibility is or can be hampered as well, right? So there's a happy medium with partial integration, but just note that this XY axis of flexibility versus cost effectiveness is something that you have to take in consideration as well. Next slide. So number 2, and this is what I previously mentioned, it's industrial onboard charger with integration and communication to EVSE. So for those who are not familiar with EVSE, EVSE stands for Electric Vehicle Supply Equipment. It's commonly known in the industry as EV chargers. So if you see any of the charging stations at your local grocery shop in the parking lot, or any of the restaurants that have these boxes with looks like a plug that would plug into your vehicle, those are industry-wide standard called EVSE. So if anyone ever says EVSE, it's the same thing as an EV charger. There's 2 types. There's one that is stationary that you usually see in the public space, and then there's another one which is mobile. So those are the ones that actually go along with the vehicle and could plug into AC outlets, whether it's 120, 240, and depending on the region or country that you're in, has different voltage variants and different actual interfaces to communicate with. So with this, traditionally, as I had mentioned earlier, it's usually discrete. So the EVCC or the module that interfaces between the onboard charger and the actual EVSC, which is the EV charger external to your vehicle, needs to be there, because if you go to any public charging station, or EVSC as it's formally known by, and you touch any of the leads on the plug, they are not active. There's not any active electric charge on any of that. So no current is flowing. The only way to get current flowing from the EVSC to the actual vehicle itself is to make sure that there's the communication protocol set up, that the authentication between the vehicle through the EVCC and the EVSC has been made. There has been the handshake to say, I'm capable of doing this, I need this. And only then is when the charger is able to, or the EVSE is able to deliver power to the vehicle. So there's more and more integration, as I said, to have the EVCC built into the charger. And as you can see on the bottom left there, there's several examples from Delta Q and Zevon of this type of implementation. If there's more questions about EVCC, I could take it offline, just ask, or we could talk about it at the end of the session. So what that entails for the off-highway mobile machinery side of things is the leverage of the current infrastructure and investments that's being diverted to the automotive sector, right? So as you could see, there's a lot of investments, and the compounded annual growth rate of EVSC charging infrastructure is going to continue to grow as the need to replace carbon emitting vehicles out there penetrates, right? So more EVs in the marketplace, they're going to need charging infrastructure to support it. So the limitations of not having electricity to be able to charge your skid steer or your loader in the past, where you would have to be reliant on connecting to AC outlet, now you could actually leverage the EV infrastructure that's out there. So that's the case study that we're seeing. Many of the OEMs that we've been working with, or that we've communicated with, have requested the EVSC or the EVCC function on their vehicles itself. They're trying to be less reliant on their integration and more reliant on the component suppliers' integration of the EVCC with the charger. So there's a lot of evolution happening with the development of off-highway mobile machinery and EVSC. Third innovation, and this is prevalent not only in off-highway, but this is prevalent along many market verticals, from consumer to industrial to automation. But basically it's silicon, it's GaN and SiC, which GaN is gallium nitride and silicon carbide is SiC. But basically those two types of technologies allow for the advancements of technology related to higher voltage, higher power, and smaller form factors, right? So all of this increases efficiency of the actual components themselves of power electronics, and thus reduces cost. As you maximize efficiency, you get more output performance from the actual product itself, and thus cost gets reduced. There is going to be an additional webinar as part of the Charger Solutions webinar series that goes into further detail about this, but I just wanted to mention it as part of this webinar, because the off-highway mobile machinery side of things are increasing in power, and silicon carbide and GaN are actually, and gallium nitride are actually going to be big drivers of new innovative technologies on the power electronics side. Okay, let's move on to the next slide. So this is the last of the innovations. It's remote control integration. So as you see electrification becoming more and more rampant, you're also seeing the migration and penetration of lithium-ion batteries. Lead-acid batteries have got us well into electrification in a lot of market verticals. It's done the job and it still continues to do the job. The advantages with lithium ion is they're usually connected to a battery management system, which is really the brains and intelligence of the actual battery itself. And not only does the communication of what's happening within the battery and the safety measures to ensure that the battery is safe and efficient, it's also has the ability to communicate out to the rest of the components in the vehicle. One of the big advantages on the charger side is that through CAN communication, the battery's BMS is now able to utilize a function within the CAN protocol to be able to control the charging parameters within a given limitation from the charger of all the charging needed that it has. What this does is it allows real time the battery to state to the charger, hey, for example, I'm within this environmental temperature condition. I need to reduce the amount of current going to the battery from the charger. Or, hey, I need to increase the charge voltage from 58.8 volts to 65 volts. I mean, that's just an example, but it's something that is capable of being done with this remote control integration. It also allows a two-way street to monitor what's happening, whether it's on the charger side or the battery side, and react accordingly. So I'm going to now walk through some case studies, and it's relevant to the industry, but some examples from Delta Q and Xeon. So one of the primary and priorities for the charger side is to really understand the battery and characterize the battery, because the battery is usually one of the most costed components on the bill of material. So you want to make sure that the user or the application developer that is incorporating the battery is maximizing the return on investment. One of those pieces to help propel that return on investment is the charger, right? So the charger, depending on how the battery characterization is, could develop profiles and algorithms for the actual battery itself so that it prolongs life, enhances performance, ensures that the proper needs and parameters of the battery are programmed into the charger itself so that the battery could get the most performance for the cost paid. The next example is from Xeon. So Xeon is very well equipped on the off-board charger implementation. So if you're looking at the picture on the slide, this is a charging room, and Xeon's chargers are able to be connected through a CAN interface, and they're all able to be monitored within the CERN protocol. They're able to they're able to be automatically controlled or remotely controlled, and it is beneficial for fleet providers of these battery equipment, because first in, first out really is a time-based implementation, and time is usually translated to money and cost, right? So by being able to remotely uh, uh, dialogue and understand what's happening with the charging sessions within each of these battery systems, right? The fleet providers could manage the actual charge performance accordingly. Okay, system integration. So this is relevant as I talk about communication through CAN bus of components, because now, unlike before, everything is much more integrated and intelligent with each other, right? So you take a combustion engine, I mean, parts of combustion engine work together with each other, but it's not synchronized heavily with each other. When you take actual components that could communicate with each other, right, through CAN bus, you could actually intelligently develop a system where every component on that system is talking to each other, and it's maximizing the performance and efficiency of those components because every component knows what's happening within the system. So as part of the ZAPI group, we provide everything out for the electrification needs outside of the battery. But with the battery side, we actually have battery partners in all the respective market verticals and application segments, because there's no one battery company that covers all different types of application needs and requirements. So we want to make sure that we're always engaged so that we could optimize the battery performance. But yeah, this is just a subset. Anywhere from motors, controllers, chargers, DC to DC converters, navigation equipment, system-related diagnostics. The ZAPI group has those offerings. ZAPI group charging solutions. As Akanksha alluded to earlier, the ZAPI group charging solutions not only has onboard solutions, but they also have offboard solutions, like in the case study, anywhere from 350 watt to 36 kilowatt. This is just a snapshot of some of our onboard charger offerings, and then our offboard. That's wall mountable. This is stationary ground. So I'd like to wrap up some key takeaways. Off-highway mobile machinery, because they want to maximize efficiency and power output, they're moving to higher power and higher voltage. What that will entail is that because they're doing so, we have to think about more integrated type solutions, save on costs, save on time to market and revenue, and really just maximize the efficiency of the vehicles itself. Enhanced connectivity, as I mentioned just a few minutes ago, related to the system integration. Enhanced connectivity could mean the differentiation between your product and your competitor's product, right? Depending on how well you're connected, not only internally as a system, but remotely, right? A lot of Internet of Things, cloud-based monitoring and using artificial intelligence to enhance the performance of your solution. I mean, there's limitless possibilities. So it's really going down to understanding what differentiates you from the competitive landscape and utilizing those tools that we actually have in place and that are going to continue to innovate and capitalize on them. Leveraging mature ecosystems, as I alluded to on my first slide, electrification is not new. It's only new in certain markets, right? A lot of the lessons learned and a lot of the challenges, the successes, all of that should be taken into consideration once you move to transition. As I said earlier, the off-highway mobile machinery transition to electrification is still in its infancy, but it could draw a lot of parallels to what's already been developed in mature ecosystems, such as automotive and the industrial space. And then integrated solutions. That's really one of the biggest innovations, but it's nothing new. I'm an electrical engineer. I was designing and developing mobile phones for good on a decade. And from the evolution of the first mobile phone, which was yay big, right? It's something that was you had to carry like a luggage, right? To what we have today, which is mobile computers, essentially. I mean, integrated solutions have played a huge role in making that uh, that progress for mobile phones. It's the same thing on the mobile machinery side, because what you're doing is you're enhancing what capabilities could be had on the component supplier side, and then the differentiations happening on the application side. So that's pretty much it. Look forward to future discussions and future sessions. Hopefully you found this informative. There are a number of follow-up sessions which Kansha will talk about as part of this Charger Solutions webinar series.
Yes, so thank you, Rod. So this webinar was the first of our upcoming webinars that we've planned over the next few months. We will be sending you this information along with the recording and presentation slides from this session. And one of the future webinars will cover the silicon carbide and gallium nitride technologies in more detail as discussed by Rod today. So now I would like to open up the floor for our live Q&A session. So please take a moment and submit your questions if you haven't already done so in the Q&A pop-up that you will see once you click on that button, as I mentioned in the beginning of this webinar. So we do have a few questions right now that we can get started with while everyone else submits the rest of their question. So what is the status of inductive charging technology? Is this something that Zappi Group is currently offering or have plans to do so in the future?
Yeah, so great question. In terms of inductive technology, there is a certain need for inductive charging. And when I reflect on this, the immediate thing that pops into my mind is autonomous vehicles, right? So autonomous vehicles basically has all the brains on the vehicle itself. It's trying to grasp where to go, what to do, all the functions that it needs to do, right? And it's powered by a battery. But lo and behold, you don't want to have that autonomous vehicle basically have to require somebody to plug it in, right? So there's autonomous vehicles right now that utilize contact-based charging, meaning um, um, there is a mechanical contact between the pads, charge pads on the vehicle itself that connect to the actual battery and the charger, which is usually off board of the battery. The issue with that is there are some mechanical constraints, there's reliability constraints, there are positioning constraints. So inductive technology does make a lot of sense when it comes to autonomous vehicles, or some vehicles that actually need precise charging metrics without the need of having to have someone physically connect or plug in the charger to the vehicle itself. So inductive technology is propelling its way. You're going to see more and more of it. I know on the automotive side, Tesla had just said that they're working on automotive wireless charging. Automotive wireless charging is heavily prevalent in the material handling space with AMRs and AGVs. The Zappi Group is always looking at different technologies, and we'll continue to look at different technologies and make sure that we're making the right investments when needed.
Awesome. And do you plan to engage in BMS development, as this is an important part that was mentioned in this webinar? That
Yeah,
is another
so
question.
in terms of BMS development, as I stated, it's the charger's job and the charger company's job to understand all the different BMS technologies out there, as well as all the different interactions with the BMS and the actual battery pack itself, right? But we're not going to be in the business of developing or offering BMSs because there's a whole variety of BMSs out there for a certain niche market, right? Depending on which market you're trying to service. Our job is to really understand and make sure that we're compatible at optimizing all the BMSs that come out to us, right? Because at the end of the day, that's only going to bring value not only to the charger solution, that's going to bring value to the battery solution. And the battery solution is really one of the main components, as I said numerous times during the presentation. It's one of the main components that is driving cost. It's driving performance. It's driving the evolution and innovation in electric vehicles. I mean, also alongside the motor and controller and power electronics, but the battery is what's driving a lot of the cost at this moment.
And how do you see the evolution? How do you see the battery voltage trending in industrial and off-highway vehicles?
Yeah, so that's a great question because I get this, I get this, or I get asked this a lot. It's really dependent on the power output and the need, right? So as you saw in one of the slides I had regarding trend adoption, and it had mentioned 30 horsepower, 30 to 125 horsepower, I believe. Dependent on the power output, you're always going to try and maximize your efficiency. So if and literally this is possible. If you wanted to do something very high horsepower, but stay low voltage, that would mean the current that you had to deliver to match the output power needed for your vehicles has to be really high. And what that does is it basically relies on all the interconnects between your power electronics and your actual drivetrain to be able to support those high currents. What that really translates to at the end of this is cost, right? So how much cost are you willing to balance, right? So when cost comes into consideration, and it really doesn't make sense versus the current incumbent solutions that are out there, that's usually when you want to start having the discussion about higher voltage, higher power, right? But it really depends on your application. Application needs, the environments, the duty cycles, the loads that it's seeing. I mean, I could walk through so many other examples and scenarios. If you guys want offline, you could contact me. As the slide has my QR code, or you could email the charging@zappygroup.com if you have further questions.
And the last question is, can you tell me a little bit more about the importance of system integration?
Yeah. System integration is very pivotal because if you saw what I had mentioned earlier regarding the generations of development, right? Usually in the first generation, because the market is still trying to prove out the solutions, system integration is pivotal because they're usually taking discrete components, individual components, and trying to marry them together, right? Make sure that they all function and work together with each other and maximize that, because if you're not maximizing that, you're increasing your cost. So system integration at Gen 1 is pivotal. Right now, unless you're someone with, or a big company with large engineering teams that have the capability to do it on their own, right? You're looking to a third-party system integrator to be able to help you with that, with all the different design and development challenges, because there's going to be a lot, especially in the off-highway mobile machinery, where the scale of EV is not really at the level that translates to lower cost, right? So you're trying to maximize that as much as possible. And system integration, as we even see internally with our with a sister company 4E, it's pivotal to ensuring that you have the right design, the right performance metrics, the right cost that's in line. As you get further down and more mature in the electrification process, system integration is going to be important, but it's not going to be essential. It's not, I mean, not essential. It's going to be essential, but it's not going to be as high a priority because now you're pushing down a lot of the developments to subsystem levels, right? You're still going to need to system integrate the solution, but now on the subsystem side, not on the individual component side. So if you look at it that way, you could see the evolution of system integration as well. But yeah, great question, because it's important no matter which level. It's just depending on which generation you're at, there's different levels of system integration as well.
Perfect. So that is the end of our live Q&A session. And I would like to thank each and every one of you for attending this webinar. We hope you found it very valuable, and we hope to see you in our other sessions that we have planned for the next few months. If you would like to stay connected with Rod, you can follow him on or connect with him on LinkedIn. And if you have any other questions, you can email us at charging@zapigroup.com. We've also posted Rod's Calendly link in the chat. So if you'd like to book a one-on-one meeting with him, feel free to do that by clicking on that link. Thank you, everyone, and hope you enjoy the rest of your day.
Thank you, Akasha, and thank you, everyone, again.